السلام عليكم ورحمة الله وبركاته. صباح الخير يا شباب. اليوم إن شاء الله بنستأنف محاضراتنا كالعادة، وإن شاء الله يمر الفترة على خير ونرجع نلتقي فيكم. طبعا حيتم التواصل عن طريق عمل فيديوهات مسجلة، وإن شاء الله بعطيكم كل التعليمات بمجرد الانتهاء من تحضير هذا الفيديو. طيب، خلينا نبدأ أو نكمل محاضرتنا اللي بدينا فيها، وهو آخر جزء من بارت الفلويد. فخلينا نستعرض المحاضرة. طيب، احنا آخر إشي وصلنا له إنه كنا نحكي عن الهيد لوس، وشفنا علاقتها بهذه المعادلة. اوكي، خلينا نحط القلم. شفنا هذه المعادلة. اوكي، وحكينا there is a relation between head loss and friction factor. This is friction factor. وشفنا هذا friction factor إذا كان في عندي smooth pipe. إذا كان smooth pipe it's only function of Reynolds number. إذا كان pipe there is certain friction, then we must consider the relative roughness. وحكينا كمان إذا كان عندنا flow laminar, this is our equation. Okay. إذا كان عندنا flow turbulent فرايحين نستعمل Moody chart. Here is the Moody chart. وحكينا بالx axis this is the Reynolds number, والsecondary y axis this is the relative roughness. ناخذ النقطة اللي عندنا معطية في السؤال وبنروح نوجد الفريكشن فاكتور أو نسميها دارسي فريكشن فاكتور. Now there is special case إذا كان في عندي fully developed laminar flow. okay. إذا كان laminar flow خلينا نزيد highlighting. طيب. So yes, إذا كان عندي laminar flow, okay, and fully developed, then the volumetric flow rate V dot، ودي إيش وحدتها شباب؟ حكينا وحدتها متر كيوب per second. Okay, so this is for horizontal pipe. If we have inclined pipe, same equation, but we'll add this term. Okay. Now we can tell that the pipe is, or if the pipe is uphill, then theta greater than 0, as well sin theta must greater than 0. So هتلاحظوا إنه هذا a term subtracted from delta B. If it's downhill, then this is negative sign, negative with negative, positive, then it will be added. Keep in mind that delta B will substitute it B1 minus B2. Let's see question. So here in this question, I think we start talking about this question. So in this question we have oil. Okay. So let me bring back the pointer. So here we have oil, 20 degrees Celsius, and هلا حكينا إنه هذا property either given in the statement of the question, or I'll bring a separate table so you can pick out these properties. Okay. So oil is flowing steadily through 5 centimeter diameter. Okay, so this is the diameter. Here is the diameter, 5 centimeter, and this is 40 meter long. This is L. Okay, this is L. The pressure at the pipe inlet and outlet are measured to be 745 and 97 kilopascal respectively. So we have P in, P out. This is B1, and here we have V2. Determine the flow rate of oil through the pipe, assuming the pipe is horizontal. So this is the first scenario, horizontal pipe, inclined pipe with 15 degree upward and inclined with 15 downward. Okay, so this is theta minus, and here we have theta positive. Also verify that the flow through the pipe is laminar. So وكأنه السؤال بيحكي لي we'll assume that this question is the flow is laminar, and at the end we'll check whether this question is laminar or not. Okay, very good. So let's move to the solution. I'll start directly with the first part. So in the question, or the slide, our slide. So here is the equation. So I will use this equation to calculate, first of all, the flow rate. So it may be volumetric flow rate. So we can use this term. Okay. So the equation told us that V dot equal delta B it's by B squared or B to the power 4 divided by 128 mu L, and this is equal. So delta B, before starting, delta B equal, as we said earlier, that it is equal to B1 minus B2, which is equal to, so if you go back to the statement of the question, you will find out that B1 is 745 minus B2 is 97. And if you use your calculator, you will find the answer is 648 kilopascal. Okay. Right. This is delta B. So we could find it. Now, also, we need the cross-sectional area. Okay, cross-sectional area. Maybe it's needed. So let us calculate the cross-sectional area. Or do you know, I'll leave it. No problem. So V dot equal delta B 648. Okay, 648. And remember that this question or this equation is for horizontal, and case A is horizontal. Okay, this is a horizontal bar. Okay. Now this is 648 multiplied by, this is kilopascal for sure, multiplied by multiplied by diameter, and the diameter is 5 centimeter. Okay, 5 centimeter, if we convert it to meter, then it will be 0.05. Okay, 0.05, and the power is power 4. Yeah, very good. Divided by 128 multiplied by viscosity, and the viscosity is equal to 0.8 multiplied by the length, which is 40. So if you calculate the answer will be 0.00311 0.00311 meter. This is volumetric flow rate, and this is meter cube per second. So this is part A. Now let's see part B. Okay, I'll use another color. Part B, theta greater than 0. Okay, so the equation for this part, so theta here equal to plus 15. Okay, yes, plus 15 upward. Okay, then this. Okay, so V dot equal to this is dot. Okay, equal to delta V minus rho G L sine theta. Okay, between brackets by b to the power 4 divided by 128 mu L, and this is equal. So delta B we already calculated, but here keep in mind that this is 648. Yeah, isn't that? Yes. Multiplied by 10 to the power 3. This is kilopascal minus rho given in the statement of the question, which is 888. Okay, multiplied by 981 multiplied by L, which is 40. Yes. Multiplied by sine 15. Close the brackets, and this is multiplied by multiplied by diameter, and the diameter here, as we said earlier, it is 0.05 over 4. All of them divided by 128 multiplied by 0.8 multiplied by 40. Multiplied by 40. And this is equal B dot equal for part B 0.027 meter cube per second. So this is part B. Now let's go to another page. So I'll change also the color. Now part C will do the same, but here we'll substitute theta equal to minus 15. Why minus 15 degree? Because in the question he said that this is downhill. Okay, so I use same equation. Also. So V dot, I can use this symbol as well if you remember. Same equation as part B. So this is 64 A multiplied by 10 to the power 3 minus 888 multiplied by 9.81 multiplied by length 40 multiplied by sine, and I substitute minus 15 between brackets. This is multiplied by multiplied by diameter 0.05. All of them divided by 128 multiplied by 0.8 multiplied by 40. Yes. So if you use your own calculator, you find out V dot equal to 0.0035 cube per second. Now, if you compare the three answers, you will find out that this is the greatest answer for downhill. Okay. So, okay. Let me go back to the first part. Yeah, here. So here, when we calculate V dot, we must multiply 648 divided by 10 to the power 3. Don't forget to do that in order to get this answer. Okay, so this is the first part. Now let's go back to the statement of the question. So first of all, determine the flow rate of oil, horizontal, inclined, upward, downward. Also verify, so this is the first part, we calculate the flow rate. Now also verify that the flow is laminar. So how we can do that? Let me go back to show task. Okay, so yeah, yes, okay. Fine. Oops. So let us continue. So the V dot for part A 0.0031, okay, and V dot for part B 0.0027, and V dot for the third part 0.00354. So one might ask, should I do the verification for all parts? No, no need. Why? Because once we verify that V dot for downhill, once we verify that V dot for this part is laminar, then the rest will be laminar. Why? Because this is the maximum amount of flow rate. Okay. Now, how to do the verification? We might or we must calculate the Reynolds number. So Reynolds number said that rho is velocity multiplied by diameter divided by mu. But here we have rho, we have diameter, we have a mu, but we don't have velocity. So how to find out velocity? So maybe Riyab or Al-Muntasir will answer, okay, or anyone from the attendance. V dot, we have V dot. V dot equal to uh, V averaged. Remember V averaged. No need to write averaged. Okay, so we might draw it multiplied by cross-sectional area. So here we need the cross-sectional area. So from this equation we can calculate V averaged equal to V volumetric flow rate divided by cross-sectional area. Okay. Now we need cross-sectional area. What do we have here? We have circular pipe. So circular pipe, the cross-sectional area for circular cross-section by multiplied by d squared over 4. And this is equal to by multiplied by diameter point, sorry, 5, oops, 5 squared divided by 4. And this is equal to point oh 1 9. I go like this because there is no space. 10963 meter square. Now, V averaged equal to point O, the answer of part C, 0.0354 divided by 0.01963, and this is equal to 1.8 meter. That's it. Okay, this is the velocity. Now, Reynolds number equal to density, which is 888, multiplied by the velocity 1.10, multiplied by diameter, which is 0.05, divided by viscosity, which is 0.8. And Reynolds from this equation equal to 100. 100 is less than 2000, and the result is laminar. Okay, so this is laminar. So if it is for the maximum volumetric flow rate laminar, then the rest will be laminar. So our solution is correct. Because why it is correct? Because we used equation that is valid for laminar flow. This equation and this equation. We could calculate V dot for A, B, C, horizontal, inclined, uphill, downhill. Then we do the verification that this equation is, or this question is linear. So that's it for today. I'll leave you with this question. Try to solve it alone, and we'll see you in the next lecture.